practice because of this vocabulary heavy information from acids and bases. So go ahead and look at problem set for me. If you go in the middle of notes, just finish that last statement you're writing, and then kind of halfway close your laptop so I can know that you have your undivided attention. You don't have to close it all the way, but you can half close. So if you're in the middle of writing something, just finish that statement. And first question I was asked to do is 5, and I'll just make it very, I think that the only difference in how would you read this question than what I'm reading it as for number 5 is it says the following hydroxide ion concentrations, and hydroxide is OH minus, not hydronium, and it says find the pH. So many of you probably just stuck that right into your POH or pH versus finding POH and then pH. So for the first one, the ion concentration for hydroxide was 1 times 10 to the negative 5th. So when you plug this information in to POH, POH is equal to negative log of the OH concentration, so 1 times 10 to the negative 5th, that should be 5, POH. So everybody, what's the pH-POH combined combination, or combined equation? Emily? Okay, so pH plus POH is equal to 14. You see 14 come up quite a bit. Why is that number relevant? Because it's the most basic pH. It also has, it accumulates the nature of the solution being acidic and basic, because you have to have a balance. So you guys can do that in your head. What's the pH? 9. Okay, give me a thumbs up if 5 you could do, because the rest of them are repetitive from there. Okay, so another note, the log logic, which is number 12. So who's done logs in math? Who's done natural logs? Double hand. Okay, and hands down. What's the how did you learn like the little log equation? Somebody tell me how you learned it, because it doesn't look quite as much like pH logs look. It was like log something, log base 10, and then what's this thing right here? X. Okay. So my log equation looks a little different than that. But what you notice is the base 10 in math class is R10 right here. Okay? So, and because I'm doing the negative log, it offsets this negative up here to give my pH a positive or absolute value that's a positive number. So log logic is if you have 1 in the front times 10, which is our base 10, you're basically saying that this exponent is x. Okay? If it's 1 times 10 to the blank, that exponent is x. I mean, that is the pH. That is whatever we're solving for. So if I give you concentration of hydroxide is 1 times 10 to the negative 3, hydroxide doesn't allow you to solve for pH, right? It allows you to solve for what? POH, right? So POH equals, what's using our log logic, because we have 1 times 10 to the negative 3, then what is POH? 3. This exponent is whatever you were solving for. So if I know the POH is 3, what's the pH? 11. How? 14 minus 3 is 11. So that's a quick and easy way of estimating or finding the pH or POH, but I call it log logic because if you understand the base 10, and you know 1 times anything is still 1, this exponent is what you're likely solving for. But it's an easy, quick way to kind of get to your answers if you're just doing estimations, not true calculations. So that's what one thing you can write for number 12. Number 13, I'll get to that actually towards the end of class, okay? So is that it for problem set 15 or 19A for now? Yeah.
Wait, 11.
Sorry, number 11. Oh, sorry, I just did number 12. So number 11, calculate the hydroxide ion concentration for an aqueous solution for which the hydronium, so hydronium, which is the same as hydrogen ion, is 1.3 times 10 to the negative 10th. And it says mole per liter. What's mole per liter? Everybody. Mole per liter. Molarity. Okay, that's just the concentration, right? And the brackets mean concentration. So I off the bat can tell you, and this is something you might want to write down, is if I'm at pH 7, neutral, I have equal amounts of species of the hydroxide and the hydronium. So at pH 7, both hydronium equals hydroxide, and they both equal 1 times 10 to the negative 7th molar. Is this number right here bigger or smaller than 10 to the negative 7th? Okay, this is smaller. So I have a smaller amount of hydronium. Is hydronium something that gives it acidic nature or basic nature? Right? So Margaret, you say acidic? Why acidic? Right, bases give off hydroxide according to Arrhenius' equation. Hydroniums come from acid. So if I have a smaller amount of something that's acidic, then I have to have a larger amount of something that is basic. Thank you. So this I already know is not going to be acidic. This because it's got such a small quantity of something that's acidic, it must be a basic solution. That's kind of the end part of that number 11. But guys, raise your hand if you could tell me how do I get hydroxide from hydronium using one of the equations. Go ahead, Julian. Okay, so she's saying this equation here. So if you have one, you can solve for the other by dividing. Okay? All right, so let's pause there for a second. I'm going to go over some of the pH formula questions shortly. So a lot of you guys said you felt pretty good. So I'm going to try to help you as I go within the labs. So the only thing I need to go over before we go to our labs are indicators, right? So we have 2 different indicators we're using today. Some of you guys are finishing up your notes still, but work with me here because a couple of these are different indicators that are going to be pretty important for you to memorize how their color changes occur. So I'm going to go from here. So, who's ever heard of litmus paper? Raise your hand. So you know there are only kind of 2 colors, red and blue. Okay? So you have to memorize the differences in colors. You're going to be using them today. But an indicator is something that's just, it's a chemical species that will change color in a solution to indicate if it's acidic, basic, or neutral. So if I said litmus or pH indicators indicate pH, what would a thermometer indicate? Temperature. What would a scale indicate? Mass, right? What would a graduated cylinder indicate? Volume. Okay, so these different tools we have indicate to us special properties or measurements that we need in chemistry. So I don't know how you remember this, but I remember it as if I was a Valley girl. Blue to red acid, okay, and then red to blue base. You just have to like rhyme it for yourself. Blue to red acid, the D and the D, right? Red to blue base. I don't know, just don't judge me. That's how I remember it. Okay, you should remember the blue and the base and the red and the acid. So, phenolphthalein, say that for me. One more time, phenolphthalein. Phenolphthalein. Most people go phenolphthalein, but there's no in there, okay? So phenolphthalein is a clear solution. That solution is really unassuming. You don't think it's going to do anything until it gets in something basic. Once it gets in something basic, it's like magenta. It's like a hot pink. We don't want hot pink. Whenever we were doing a titration, which we'll do on Wednesday, you actually want really a faint color of like Barbie baby pink. Not this bright pink. That means you've overshot your titration. We'll get into that soon. But these are the 2 indicators you should know a lot about. The other one we're going to use is cabbage juice, which we'll get to today in the lab. But you can see there's many, many, many. My favorite one is methyl violet, and it changes its color at about pH of 1.5. Where's phenolphthalein down here? It's down here. You can see it. It changes over here from colorless to pink at about 8 or 9. Where there's other ones, bromomethyl blue. Who used that in biology? Bromomethyl blue. Thank you. It has like a pretty neutral color change at 7. So it's going from yellow to blue at pH 7. So different indicators change at different pHs. We're going to use cabbage juice today. Okay. Yeah. Question, Nick.
What is used to calculate the pH of a pool?
Used to calculate pH of a pool, like pH strips itself. There's pH strips that are Hydrion. Hydrion is like the brand name, and they can use pH strips, or they can actually use universal indicator, which has like 4 or 5 of those I just showed you, all in it together, so it has a color change at every single pH. Okay, so these are some natural ones. So on your on your holiday break, you could possibly make your own pH paper just for kicks and giggles, and you can actually see color changes from their normal form, so maybe if they're normally acidic in nature, to their basic form if they change color. So who drinks grape juice? Okay, so my husband and I are nerds, and we were like, let's see, this actually changes color. And we had the grape juice, and we put in like some vinegar, and then put in some like ammonia because it's basic, and we saw the color change. So he does endure my interesting side trips in the kitchen. Okay, so acid base indicator lab. That's going to be your first lab that you attend today. I'm going to go ahead and pass out some papers for that, but there's another lab you're doing on top of that, and I'm going to have it serve kind of an inquiry. Inquiry means that you're going to have to think, you're going to have to ask each other questions, you're going to have to analyze results as a team, and I'm going to come around and help to guide you, but I'm not going to straight up tell you the answers, because, yeah, that's a little bit before. So it doesn't recognize that you're an intelligent human being, okay, by just straight up using it. So the first lab you guys are doing is a cabbage juice lab, and yes, it's going to smell like cabbage. Waft it. What does wafting look like? Waft with me, okay. So you're going to have to waft it if you want to waft it, but it starts off purple. So it starts off purple, so turn back here for me. This is neutral, pH 7, neutral. And then I have a couple of different stations set up, so bear with me here. These are called the nodes, pHs 2 through 12. You'll see that on your paper as 3 through 12, but you just have to make a note that you have a 2 or 12. You're going to have to add these to your cabbage juice into these little well plates. So keep them around for me. These are little well plates, and you're just going to drop cabbage juice, and then your actual true pHs, and you're going to see their color changes. This is your known plate. Like, I know what these pHs are. I know what the color changes are. Then you're going to compare that to. So I've got two different sets. Okay. Okay, yeah, sorry. So I've got these in my bucket. These are the kitchen samples. So I've got lemon juice, Sprite, kitchen cleaner, Tums solutions, things like that. And you don't know their pHs, right? I don't know the pHs. You're going to call those your unknowns, and you're going to compare them to your other colors to see what their actual pHs are. So I have a couple of those set up. So don't move these. These also have little pipettes to go along with them. If you contaminate them, I will haunt you in your sleep. Okay? I make those, or Justin makes those. We kind of trade off. I also have one on this side, so these are knowns, and these are unknowns. The purpose of the lab, I'm going to share it here. The second lab, I'll probably stop you guys after you get toward the end of the cabbage juice lab, and I'll explain that one to you, okay? But it's on the back of your paper. So let me tell you your new lab groups. Lab groups? You guys have gotten so comfy with each other. I want to make sure that you are still making new friends. Is that too little? Can you see that? Maybe make that just a little bit bigger. Okay, lab station 1. Maddie, McKinley, Brittany. Lab station 2, Lael, Cameron, the Caroline, and so forth. Give me a thumbs up if you know where you are. Robbie? Wait. Whoa. Say again? I'll push you into... I'll put you in Lindsay's group because Chloe's not here either. Lindsay, Robbie, Caroline, you're lab station 2. You have 1 minute to get goggles and move to your station. You will need to pull out your lab notebook though. I might have to reorganize the labs a little bit when we get back there. Miles, you are, oh sorry, not Chloe. Miles, my bad, Chloe Z. Miles, you're gonna pop, you guys are combining together.
Alright.
Yeah. Audrey, my bad girl. Will you clump with, go with, pick a group, Audrey. Actually, you know what, Audrey, go where Jacob is. Where's Jacob? Come back there. Go with Emily. Thanks, darling. Alright, I'm coming back to help you, but give me 1 second. Surprise. Finish your notes and start your homework. Here we go. Goggles. And one person to come get goggles. Here you go. Did it bring your
Oh, that's it's going 1, 2, 3.
Alright guys, let me give you one more tutorial, okay? So while Rishi and Nick are doing their thing, you guys can see they're just coming in order. They're bringing their little ball plate over here. pH 2, 3, 4 through 12. This is the same set over here. This is I think that you have it pH 7. So I should see one person from your group coming into the standard, which are the knowns, and then you can have someone from your group also going in to get the unknowns, which are at these 2 stations here. Now, this is easy to go in order, 1 through 12 or 2 through 12. Those are, oh gosh, I better write down what I put in 12 because that doesn't have an order, right? Like kitchen spray is spray, doesn't have an order. So you need to make sure you know which well is which whenever you get there. I should see people moving very soon. Wait, wait until I know there's a lot of people up there. Wait, you won't know what they are. Well, what's a well? What's that? Wait, Cameron. Do you want the instructions? Okay. Guys, keep the pipettes with them. Wait. your groupies to come back. Go ahead and look at the analysis questions so that you can have a conversation about those. You shouldn't be sitting there like a lump on a log. I have the vinegar in another container. I have vinegar.
Should have put them all together like that. Okay. 15 drops of cabbage juice. Cabbage juice. We don't have droppers. We do have droppers. You want to keep going? Color of the indicator. What is this? Okay. Well, actually, we don't already got it. Want to start from the top? Go down? Or like start from the top of the chart and go down? So, oh, this is all. That is very light. Ugh. Soft. All right, we're going to start with B2. Is that the first one?
Alright guys, so as you're starting to see color changes, raise your hand if you're adding cabbage juice right now. I see most of us. I want to see some, like, interesting, differentiated colors. It shouldn't be like, oh, green, forest green, or lime green, or Shrek green, I don't know. Something that notices the differences between these colors, because it needs to be differentiated. If not, it won't describe it well enough. Oh my gosh.
Yeah. We'll just keep going through this though. B1. Alright, let's face that.
I'm not even using it.
Well, pale purple? A4.
Two more.
We're gonna start counting.
Yeah.
Do you want to do the next one and then I'll do all one?
I mean, I just. Which one? B3?
You okay so far?
I just have one question with this number that you said for 1, 2, 3 for hydrochloric acid. Is that a constant or is that just a number? It's just an amount of the liters and multiple liters. So that could be whatever the
What is what? pH2, they're in order. No, they're not. pH2 is not on the paper. Please stop. She told you to write it down. Please slow down. I know you're doing it. No, I'm not actually. I'm not doing it.
Yeah, so like this is my Yeah.
So I would do that for some check. And the next one's equivalent to that for you. They have some balance. When they get some back up, they can do it right. And this is like, this is their thought and sensitivity. I don't think not every time, but, and then I'll use the other day, they have a great promise and they're waiting on me. They have just like this, and that's easy.
Yeah.
I'm curious about the snowballs. Oh, they were just. This is.
I don't know if you did them or not.
We
But
did
I'm
them
not
last
ready
week.
to
And I was like, what is this? So this one's using oil currently. This is for the beer, other bubble. And Sarah Jewel. This is baby oil.
I know, but
This is
some
all.
ladies
That's in salt. And they have it raw for the. And this is oil. We tried talking about it on the amazing show, just don't work. But what was funny was they had to see it first. It's all. We don't want it to look generally. We want to use chips. So they can just put, if we don't want it salt.
Is that how like snowballs are traditionally made? You know, we put it on. I was curious.
Yeah, but they worked out well. But there was oil, like all of
Yeah.
them. But yeah, we'll talk.
Is concentration the same thing as molarity?
Yes.
Alright.
And the brackets
Guys, as you're matching your colors, there is no rhyme or reason. I'm not saying that there's one of each of the pHs. I'm not saying there's not more than 2 pHs. You're just matching your colors as best you can.
What's this?
Looks like A6.
Well, that's. Or is that A5?
Or
Are we gonna like match them?
Versus the most consistent. Sorry, I didn't do it. I wrote, I know what you did.
What was that one? Oh, that's 5. Okay, 5.
yes, guys, you should have this bright urine colored yellow.
Oh,
Yes, do you have this bright yellow? First off, let's go ahead and close that cabbage juice because I can already smell it, and I'm going to say it was you guys, but if it's a cabbage juice, let's just close it up. But yes, you should think about how our colors made, and maybe you'll figure out where that yellow belongs on the pH scale. I believe in you. But in about 5 or 6 minutes, I'm going to make sure that we're cleaning.
Yeah. Or no, not all the rest.
Well, you can test it out, double change it because some of the stuff on the notes for the booklet and the booklet's great too, so
Their videos like that.
I fixed it so it would work. I even tried it.
Should I finish the video if I understand how to do PS13A?
Just in case.